Good morning, everyone. My name is Mark Fuchs. This presentation is from Work Group 4, Biomass to Biochar workshop. We focused on biochar and composting. I'm a co-lead with Dr. Tom Jobson from Washington State University. We have members including an operator a compost operator from the state of Washington, air quality expert from California, and a soil scientist from Washington State University Extension. I was also one of the originators of the original workshop. This is the overall concept that we want to get across. We want to be able to stabilize and reduce greenhouse gas production from thermal and compost, from burning and compost production. And we want to be able to sequester stabilized carbon to soils to improve soil productivity and also to draw down carbon. So in the red hatched box on the left, you can see the feedstock sources: forestry, agricultural, and urban. And just a note on the municipal sources or the urban sources, the U.S. Forest Service produced a research note here years ago that showed that the municipal woody biomass is greater than the harvested biomass from forestry production on U.S. forests. At any rate, these feedstocks would be the source for biochar production. They would go through the biochar production process, and the biochar would then be added into the composting process. The right-hand box shows the compost process and the sources of urban and rural feedstocks that go into compost: biosolids, green waste, food waste, and woody biomass, animal waste, and food processing waste. I would note that as compost is finished, the compost is screened for the final product, and the overs from that screening go back to the front end of the composting process and are used as porosity in the compost pile. That source of woody sticks and twigs would be useful to go back into biochar production as well. So why do we want to add compost to biochar? Biochar acts like activated carbon, absorbing gas emissions and soluble liquids in the compost pile. It helps to increase the rate at which compost is finished. And biochar helps to contain or maintain the loss of nitrogen and sulfur and carbon compounds within the final compost. So our goals are to reduce greenhouse gas emissions, reduce odor emissions, increase nutrients and stabilize carbon from the final compost, improve plant health and yields, not only for farmers, but for gardeners, landscapers, road right-of-way stabilization, parks, golf courses, wherever on the landscape compost would be useful, and to also increase the carbon value for offset markets for greenhouse gas reduction and greenhouse gas emissions. Our concept is a 5-year biochar project to maximize carbon drawdown, minimize emissions loss, demonstrate carbon life cycle benefits, and assess profitability. We know that there's large quantities of available biomass across the landscape. We know that municipal feedstocks range by source and season. Ag manure is a fairly consistent material, but there are complex emission and odor profiles coming off of these various composting processes with variability in feedstock and season. And biochar, again, acts like activated carbon to reduce emissions. Some of the challenges are that the current industry is based on tipping fees, and the cost of biochar would be an additional cost to the compost. Can current biochar production produce char with the necessary attributes? We need to be able to build public and private confidence in the final products, to add value to the compost operator and user, reduce emissions, and add value in the end product with captured nutrients. I want to clear up something that I think I misspoke on a previous slide. I said add compost to biochar. Really what we're proposing to do is add something like 5 to 10% volumetric biochar to the compost feedstock and then carry through with co-composting this mixture of biochar and compost. We know that biochar reduces odors from emissions of nitrogen, sulfur, and carbon compounds, as well as greenhouse gases from the composting emissions. But we need to be able to match the biochar absorption properties to the emission profile, and then carry through with compost trials to evaluate char mixtures and various feedstocks. We want to be able to test that on municipal feedstocks, given that the seasonality and the municipal sources, and on agricultural manures, and evaluate that in lab and small scale, and then move to near commercial demonstration scale, and assess the emissions and carbon footprint at that near commercial scale, and then evaluate the value to the compost operator and end user. We are proposing a 5-year project. It's science and technology based. The experimental design would be led by an academic research team and focus on carbon life cycle outcomes and economics. We propose that the U.S. Biochar Initiative and the U.S. Composting Council would be coordinated project leads. Biochar would be produced from current producers, and we would do field studies at commercial compost facilities, and we would work with a coordinated team of experts and technical staff from the industries. We know that biochar influences the composting process in some of the ways I've noted, but we also know that the process of composting improves the characteristics of the biochar by enhancing the functional properties of the char, which can increase its odor and greenhouse gas absorption. We're proposing a 4-phased project over 5 years. Phase 1 would be research, a laboratory and small-scale trials. Phase 2 would be a near commercial scale field trials phase. Phase 3 would be data evaluation and modeling, and a 4th overall project reporting phase, which would be throughout the length of the project. We're proposing a budget of $6 million over a 5-year project over these areas of expenses. I want to thank you all for listening in. My name is Mark Fuchs. Here's some contacts to follow up with: Dr. Tom Jobson at WSU and Tom Miles at USBI.